To secure your IoT devices, you regularly use certificates. There are changes coming up for TLS certs, and we have one of our top security resident experts, Ramit from the Azure IoT team, on the IoT Show today to tell us everything you need to know about these upcoming changes and the call to action for you device developers. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we'll talk security. We'll talk more specifically about Azure IoT TLS certificates and upcoming changes. And for that, we have Ramit from the Azure IoT engineering team with us. Ramit, thanks for joining the show today. How are you?
Thanks, Olivier. I'm happy to be here. Thanks for having me.
Ramit, before we jump into the actual topic and the real reason why you're here, like beyond just chatting with me, we need to actually know a bit more about yourself. Who are you? What are you doing at Microsoft these days?
Perfect. Yeah, sure. So my name is Ramit Malhotra. I am a program manager in the Azure IoT team. I have a background in cloud and device security. And I've been at Microsoft for 5 years now, doing all kinds of security stuff. My role today is to handle the security of Azure RTOS and devices and developers, which basically means that my job is to ensure that all devices that use our SDKs to connect with Azure are secure and connecting securely.
Makes sense. So we are using certificates, like similar certificates to the one used in the web. But before we actually look at the change and discuss the changes that are coming, can you give us a one about TLS certificates? What are the basics?
Sure. Yeah. I've often struggled with how to explain certificates on the internet, and then I realized that they're very similar to how we, trust signed documents in the real world, in the physical world. So if I send you a document with my signature on it, how do you know that I am the one who has actually signed the document? And typically how we solve this problem in the real world is that we've got a trusted third party that stamps the document. In the real world, it's called a notary. So we go to the bank who can notarize the document, and then the party that's receiving the document trusts that this was indeed signed by the person who signed it. Trusts work similarly on the internet. When you, for example, go to bankofamerica.com, how do you know you're talking to Bank of America in reality? It's because they've got a certificate that is issued by a trusted third party that everyone on the internet has agreed to trust. Now that trusted third party is called a certificate authority. So why is that essential? It's essential because that's the way everyone trusts identities on the internet. Otherwise, you could be talking to a fraudulent website, and in the Bank of America's case, you could be giving away your hard-earned money because there was no trust between you and the website you were interacting with. So that's why certificates are super essential. They establish identities. They also encrypt data, which is very important because there are obviously very, very confidential interactions that happen on the internet these days, and we don't want that information to get snooped or to get sniffed by parties who are trying to defraud customers or to defraud people on the web. So let's talk about certificates and how they work in your browser. Now, if you can see, we've got a screenshot of us trying to connect with azure.microsoft.com. And there's a little lock symbol in Edge that shows that the connection is secure. Now, when you click on the lock, it shows you a bunch of things. It shows you that the certificate is valid. Now, when you click on that particular certificate, it opens up the window on the right. And if you click on the certification path tab, you'll be able to see the entire certificate chain. Now, I know I'm using a lot of terms, and we'll get into that soon. But what I'm trying to show you here is that DigiCert Baltimore root that you can see is the notary here that we had used as an example in the previous slide. And that root certificate has issued Microsoft another certificate called Microsoft IT TLS CA1. And that certificate has issued this website a leaf certificate called azure.microsoft.com. Now, whenever someone connects to azure.microsoft.com, they will be presented with that leaf certificate. And the way they trust that certificate and trust that they're talking to azure.microsoft.com is by looking up this chain and seeing that, oh, it was issued by DigiCert Baltimore root, and we trust this root. And that's how trust will be established. So I know I said a lot of terms, and the chain of trust is super important. So this is how the internet works. There are root certificates that companies like DigiCert publish, and those root certificates issue intermediate certificates to corporations like Microsoft. And then Microsoft's intermediate certificates issue leaf certificates to web assets like websites like Azure.com and IoT Hub, etc. And those finally connect with end users and customers. And that's how TLS works on the internet.
Awesome. Thanks for the 101. Actually, it's very useful. So more specifically then, how does it apply to IoT? How are we leveraging these same certificates and the same model for IoT devices and authenticating them with Azure IoT services?
Yeah, that's a great question. So IoT devices, as you know, Olivier, they're varied, and there are all kinds of devices. We've seen devices that cost a couple of cents all the way through thousands of dollars. How do we distinguish between them? And for the purpose of this conversation, what do we have to keep in mind while talking about or thinking about secure connectivity on the internet? Now, we broadly categorized both IoT devices into two categories. We've called them MCU devices and MPU devices. Now, the way we think about MCU devices is that these are small constrained devices which don't have a lot of processing power. Think about sensors that are placed in farms or in logistics in factories, etc. These are very small, and typically they don't have what I like to say modern operating systems like Windows or Linux running on them. So they could have real-time operating systems running on them. They could have custom firmware running on them. So how do we connect these small constrained devices to the internet and establish trust with other internet assets? We typically use certificates and we burn them into the device with the firmware. In these cases, the best practice that Microsoft recommends is to pin the root certificate. What does pinning mean here? Pinning simply means that we specify a list of certificates that we will accept while talking on the internet. All other certificates that are presented to us will not be accepted. That's called pinning a certificate. So we recommend pinning root certificates, and we highly recommend having a robust update story. I cannot say this enough. We highly recommend having a robust update story. Why? Because the internet is not a very pleasant world. There are people, bad actors trying to get your information, to get your money, to defraud you. And because of that, certificates sometimes get revoked, they expire, they get leaked, they get compromised. In all these cases, it's very important that servers that are presenting these certificates to clients like IoT devices, they rotate and change their certificates regularly. And therefore, it's very, very essential that every time these changes occur, IoT device owners can update these certificates on their devices easily and continue talking on the internet in a safe and secure fashion. Talking about MPU devices, the way we think about MPU devices are devices that have processors that are capable of running operating systems like Windows or Linux. In these cases, these operating systems have something called certificate stores. And certificate stores have trust bundles with lots of root certificates already installed, ready to go. So in these cases, the recommendation from Microsoft is use operating systems, make sure that you're updating the OS regularly, and with each update your OS cert stores will get updated with the latest and greatest certificates on the internet, and the bad and stale certificates will get removed. So for MPU class of devices, I'm a little less concerned when we talk about changes of TLS. With MCU class devices, we have to be very careful, and remember, updating is always recommended.
And I like the way you're putting some stress on that. You need to understand what's going on in your device, right? So the pinning on the MCU is definitely a high level of control, but it's not because you have Windows and Linux or Linux that actually takes care of the cert for you that you should not understand what's going on there, right?
Right, absolutely. I think it's essential for every device owner or device developer, embedded developer to understand how trust works, why there are certain certificates that you should pin, what the trade-offs are, the more granular you go into the cert chain. These are trade-offs that all developers need to understand. But again, Microsoft recommends for IoT devices, pin the root certificate, and you will have a happy connectivity story to Azure.
So as much as I enjoy the conversation and how much I'm learning about things, how things are done for TLS certs and how they're used, there are things coming in terms of changes for the certs in the realm of TLS. And well, you're here to tell our developers what's changing and then what they have to do about it. So let's look at the changes. What's going on there?
Absolutely, yes. This is why I'm here, Olivier. And there are changes coming. There are changes coming across Microsoft when we talk about public key infrastructure, and there are changes coming to IoT services as well. Let's talk about what's happening in Microsoft and when. So, why are there changes coming? Now, a couple of things have happened this year. And let's get into the top thing that has triggered this change for October of 2020. So, on July 1st, the Certificate Authority Browser Forum discovered that certain certificates on the internet were not complying with a baseline requirement. Now, I don't want to bore you with these details, but the impact of that was that all four of Microsoft's intermediate certificates that were issued to Microsoft by the Baltimore root certificate were impacted and they were non-compliant. Now, I want to stress
But
this
not
again.
compliant doesn't mean not secure, right?
It does not. That's what I wanted to stress upon. Non-compliant does not mean non-secure. In this case, certificates are still secure. It's just a compliance issue which has forced us to decommission these certificates over the next 6 to 8 months. So, because these certificates had to get retired, Microsoft decided that for most of Azure services, we are going to change our public key infrastructure. What does this mean? This means that our root certificate and our intermediate certificates will change. The red box that you can see on the screen, that shows the things that are changing for us. The root CAs will change. In this case, we are going to go ahead with a new certificate authority root, which is called DigiCert Global G2. This is a very popular root certificate in trust bundles across the world. And this one will be cross-signed by another certificate that Microsoft owns and mints. It's called the Microsoft RSA Root Certificate Authority 2017, which forms Microsoft's own public key infrastructure. Now, the future of Microsoft PKI is that we want to transition from third-party PKI providers to our own PKI, which is called MSPKI. So eventually we'll get there. But since MSPKI is still new and it's not trusted across the world yet, we are cross-signing or using DigiCert Global G2. Now, DigiCert Global G2 has issued Microsoft 4 new intermediate CA certificates. Those are called MS Azure TLS, issuing CA 1, 2, 5, and 6. So now ICAs, the new intermediate certificate authorities that Microsoft uses, will now be changed to this new route. Now, of course, since this PKI is changing completely, the new Leaf and N-entity certificates, in our example, if you remember, we used azure.microsoft.com. Now, those certificates, of course, will also change because the intermediate and roots have changed, and the entire chain, therefore, has changed. Now, IoT services also get impacted here. ADT, TSI, IoT Central, MCVP, device catalog services, all these services will be changing their server TLS certificates so that they are rooted to the new DigiCert Global G2 certificate.
I'm not going to ask you what happened to the number 3 and 4 ICAs there, but in general, so I'm seeing here IoT services, ADT, TSI, Central. What's going on with IoT Hub and DPS? Well, they're not in that list, but what's specific about them?
Well, excellent question. Now, of course, IoT Hub and DPS are very, very important services for Azure IoT. Why are they important? Because all devices connect primarily with these two services. So because all devices connect with these two services, we decided that it's this timeline of changing to the new public key infrastructure is too aggressive for our customers. A lot of devices are sometimes in locations that are not easily accessible, or they are not easily updatable. A lot of devices also have limited connectivity and therefore cannot quickly change certificates. Just so that we help our customers transition smoothly, we've decided that IoT Hub and DPS services will stick with the Baltimore root certificate. While they're sticking with the root, their intermediates will still change. Why? Because the entire point of this was that our intermediate certificates were deemed to be non-compliant by the Certificate Browser Forum. So our intermediate certificates will change. If you see in the box there, we've got the old ICAs. We've got Microsoft IoT TLS CAs 1, 2, 4, and 5. The new ICAs that Baltimore has issued us are only 2. They are Microsoft RSA TLS CA 1 and 2. So to summarize, IoT Hub and DPS will stick with Baltimore as their root, but will change their intermediate certificates to the newly compliant certificates issued to us by Baltimore.
Yeah, no,
Interestingly, Azure Storage will also change intermediate certificates. That's because our SDKs allow devices to talk directly to Azure Storage services. Now, we do not want that feature to break. We recognize that a lot of devices do upload files to Azure Storage directly. To preserve that feature, to ensure that that feature continues helping and delighting customers, we've ensured that Azure Storage remains on Baltimore, and they will also be changing their intermediaries to one of the two Microsoft RSA TLS CAs 1 or 2.
nice. I think the developers will appreciate that we're not basically putting a knife under their throat and tell them, hey, you have to change everything now on your devices. As you were mentioning, especially as some of these devices, or whether, under dirt, or they have a life cycle that actually, might not allow them to be updated anyways. But there's still an elephant in the room here. You're saying, hey, we're going to keep the root CA, the Baltimore one. But as we've already discussed or seen in discussions in the past, or developers starting to ask, that root CA expires soon in 2025. So how are we addressing that? How, what's the plan there?
Well, that's an excellent question, Olivier, and that is definitely the big elephant in the room. Remember, I started my conversation in the previous slide saying that a couple of things happened this year. Now, one was, of course, that we had found out that for all four of our intermediate certificates were non-compliant with one of the baseline requirements. However, the other thing that we were anyway working towards was the expiry of Baltimore. Now, as you already mentioned, Baltimore does expire on May 12th of 2025. And there's nothing anyone can do about it. This is the life cycle of the certificate. Now, what happens when the root certificate expires? Of course, we have to switch over to a new root certificate, and that changes, of course, the entire chain of trust from the root to the intermediates all the way to the leaf certificates. So while we are working on this, we recognize that this is a severe change for devices. This is something that will impact almost every single MCU class of device that does not depend on operating system certificate stores. Because of that, we realize that we have to give customers enough time, enough runway for them to go in and update the devices, the certificates on the devices, or in some cases recall devices so that they can update them manually. It's a costly effort, but it's the cost of doing business on the internet, and for that we do have a plan coming in. So what's going to change in 2023 for IoT Hub and DPS? As mentioned, most of Azure services and most of IoT services in September, October of this year will change to DigiCert Global G2 as their root, cross-signed with the new MSPKI CA. In 2023, IoT Hub and DPS will also align with the same plan. They will also move the root to DigiCert Global G2, and they will get new ICAs that will be issued by that certificate authority root. The ICAs are called MS Azure TLS issuing CA 1, 2, 5, and 6. So in 2023, IoT Hub and DPS will meet their friends from Azure and align and have the same exact root certificate.
Nice. We'll talk about that in a little, and I think that the timeline is definitely what we're looking at. But developers could eventually, if they update their devices, go directly to the new root CA, right? They don't have to go through that intermediate story. They can definitely switch their certs and pin the new root versus waiting for the change in 2023. Correct?
Absolutely. There's nothing, all these certificates are available today. There's nothing stopping any device builder to go in and update the certificates today to have all the three roots, to have the Baltimore root, as well as the MSPKI root, as well as the DigiCert Global G2 root. In fact, that's something that we recommend for everybody who is in a position to update their devices in this time frame, in the September-October time frame. I think Microsoft recommend.
Yeah, so Ramit, let's actually sum it up for our developers here. So this change is coming. They have actions to take. They have few options here depending on the devices types and so on. I think you have a timeline that actually really will help them understand when they need to do what. What's the call to action here?
And this brings us to the meat of this conversation. What do developers have to do? What's the action item here? So I've created this slide which talks about the timeline and the calls to action for each event that's happening in the next 2 years or 3 years. all the way through October 26th, we will start production rollover of the intermediate certificates and therefore the leaf certificates of Azure IoT services, specifically IoT Hub and device provisioning service. Now, what do developers need to do to see if there is an impact to them? They have to scan the code. They have to scan the code that lives on their devices, the firmware or whatever application is running on these devices and talking on the internet, to see if they have pinned any intermediary certificates that are on path to decommissioning. We've already mentioned the names in the previous slides, so I won't go over them again. But basically, if you have pinned an intermediate certificate or a leaf certificate, Microsoft's recommendation is that you replace those certificates with the Baltimore root certificate and the MSPKI and the DigiCert Global G2 root certificates. What this simply means is, in the list of certificates that the firmware decides to accept as a valid, trusted certificates, we recommend adding all three roots: the Microsoft PKI root, the DigiCert Global G2 root, and of course the Baltimore root certificate that is going to be valid until we move off of it in 2023. Now, what happens in 2023? Before 2023, we will do a formal announcement regarding this change for IoT Hub and DPS. That will happen approximately in March of 2021. We will announce the change and we will announce an action plan. Remember that we understand that this is a big change. We want to ensure that our customers don't face any losses of connectivity to Azure. We want to give customers enough time so that they can go in and make these updates and ensure that their customers also have enough time to make changes on their end. So in March 2021, the plan is to give customers about 18 to 24 months to make these changes. And then Jan 2023 is when we plan to move off the Baltimore route onwards to the MSPKI and DigiCert Global G2 public key infrastructure. Now, in between all of this, again, I can't stress enough, it is so very important for us to have a mechanism to update TLS certificates. It's not just because of issues like, intermediate certificates not complying with certain requirements. It's because we live in a world where fraud is very prevalent. We live in a world where everyone is trying to access and hack and compromise systems on the internet. Certificates keep getting compromised. Because of this reason, in order to safeguard your devices, in order to ensure that there is trust between Azure and your devices, we need a way for every device to update their TLS certificates easily in a robust manner, so that issues like this don't result in us having to recall devices or result in us having to lose connectivity to Azure.
Perfect. I think this is definitely a good reminder. Good practices in terms of security. Ramit, there was a very important and interesting discussion we had today. You have a blog post that if you want to read that blog post with all the details and all the links to documentation and call to actions and so on, you can check out this blog post at aka.ms/IoT show/IoT-CA-updates. Ramit, thanks a lot for joining the show today. I hope to see you soon.
Absolutely. Thank you so much for having me. And remember, be safe.
Be safe, everyone. Thanks for watching the IoT Show. Do not forget to subscribe, get the notification. I see you soon. Bye.
Thank you. Bye.